In this video, I introduce hierarchical diffusion models for text-conditional image generation. unCLIP is a high-resolution image generation framework in which a trained clip is used to generate a text embedding that a diffusion prior uses to produce image embedding. And then this image embedding is used to condition a diffusion decoder to produce a final image as shown here. This clip model and this unCLIP framework. The training dataset consists of pairs X, Y of images X and the corresponding captions Y, as shown here. This X and this match the caption Y. Given an image X, Zi and Zt are the clip image and text embeddings. unCLIP generates images from captions using a diffusion prior P and diffusion decoder P here, from here and here. The diffusion decoder uses the text and image embeddings to generate images, while the diffusion prior learns a generative model of image embeddings. The conditional image generative model is defined here. We insert Zi here because Zi is a deterministic function of X. We use the chain rule to split this probability into product of two probabilities, this decoder model and this prior model. The generative model is split into two stages, namely first Zi is sampled from the prior distribution P, and X is sampled from the true distribution P. The diffusion decoder takes the time step, text, and noise the image embeddings as input to generate a high-resolution image, as shown here. This input and this output through two upsampler from 64 by 64 to 1024 by 1024, as shown here. This 64 by 64, 256 by 256, and 1024 by 1024. Using the trained clip is because the clip text and the image embeddings are in the same latent space, which allows us to perform image manipulations. The diffusion prior model produces image embedding Zi from the caption Y. For example, Gaussian diffusion model is used to generate image embeddings Zi conditioned on the encoded Y and clip text embedding Zt. The prior model is a decoder-only transformer with a causal attention mask that uses as an input time step embedding encoded text clip text encoding and noise the clip image embedding as shown here. The output from the transformer is used to predict the image embedding ZL as shown here. The diffusion prior generates two samples of Zi, for example, Z1 and Z2, and then select one with a higher dot product with Zt as shown here. The diffusion prior loss function is defined here, where Zi is a noised image embedding. To use a classifier-free guidance, and both diffusion prior and the decoder randomly drop conditions 10% of the time during training. For more details, please check with these references. Thank you. Bye.